With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply state a thin horizontal disc of radius 10 cm is located within a cylindrical cavity filled with oil whose viscosity is 0.08 poise. The distance between the disc and the horizontal planes of the cavity is equals to h, and h is given as 1 mm here. Find the power developed by viscous forces acting on the disk when it rotates with angular velocity of 60 radians per second. The end effects are to be neglected. Now let us draw a diagram for better understanding of this question, right? So you can see that these are simply these vertical surface, and in between them there is fluid, and a disk is simply rotating like this. So this is the disk, and what happens is that the liquid is simply filled in this entire space like this. Now you will understand why this will develop some power. Now this disk is simply rotating about this axis with some angular velocity omega. Now let us try to understand what will happen here. This is oil simply which is filled in between these. Let us try to understand what will happen on this surface of this fluid. Now you can see that the velocity of the fluid here will be simply equals to 0, but the velocity of the fluid which is here, which is in contact with this disk, will be simply rotating with some velocity. Let us say that it is at a distance small r, right? Let us say that it is at a distance small r, so it will have some velocity v equals to r omega. So this liquid will simply rotate with the disk while the upper liquid is simply stationary. So you can see that some velocity gradient will develop between the layers of the liquid, due to which there will be some viscous force. Now due to those viscous force there will be some power which will be developed. Let us try to find out that power. So to find out that power, let us take an elemental area from the center line. So the elemental area. So when you see this disk from the top and you take a liquid element, you can see that I have drawn a liquid element. When you see from the top, this is simply the top view for very clear understanding. So when you see from the top, there will be some element, and what will happen is that, let us say that the thickness is dr, it is at a radius of r from this axis, right? So what will be the velocity of this? It will be simply v equals to r omega, right? Because all the element will be simply rotating with same angular speed. Now what we can do is that we can find out what are the viscous forces which are acting on this, right? So how do we find out the viscous force? We found out the viscous force by using the Newton's formula, which is coefficient of viscosity into area of this element into the velocity gradient, right? So what is the velocity gradient? It will be simply dv divided by h. Let us take this distance from here to here. This clearance is simply h. Now we can find out the velocity gradient very easily from here. You can see that the velocity here is simply nothing but it is v, and the velocity at the top surface is simply nothing but it is 0. So this, at this point, right here, the velocity, sorry, here the velocity will be simply 0, and at this surface the velocity is simply r omega, and you can see that this is v and this is h. So if you find out the velocity gradients, del v divided by del h, this will be r omega divided by h. Now we can substitute the value. Let us first try to put the area. So what will be the area of this element? It will be simply 2 pi r into dr into omega r divided by h. But we have to find the total force since there is liquid on both sides, right? And we are assuming the total depth. This is also h. So the total force will be simply nothing but this will be 2 times of this force. So this is 2 into eta into this is 2 pi r square dr into omega divided by h. Now how do you find out the power of a force? Right, so you can find out the power of this total. So the power of this viscous force total viscous force will be simply nothing but F total, that is acting from force, viscous force, which will be acting along this direction on both the side of this element, right? So this is the viscous force and this is the velocity. So how do you find out the power? You multiply total force by velocity. So now what you are going to get, this is 2 into eta into 2 pi r square dr into omega divided by h, and in place of v we can write r omega. So now this is simply the power which is developed by this element. Now we can also call this as dp, right? Let us call that as dp. That is the power developed in this element, right? Then we will integrate it to get the total power. So you can see that all these parameters are simply constant. So we take them out. This is nothing but, this is 4 pi into eta into, this is omega square divided by h. All these parameters will be simply constant, and what we are going to get is, we are going to get, this is r cube into dr. Now we can integrate this from 0 to r to get the total power, right? So the total power will be simply nothing but, this will be 4 pi eta omega square divided by h into, the integration of this will be r square divided by 4. So this will cancel out. Now we have been given the value of all the parameters, and remember we have to put in SI units. So pi is simply pi, and in place of coefficient of viscosity we have been given in poise. So we have to put it in Pascal seconds, and that will be simply 0.08 into 10 raised to the power minus 1, and omega is given to us as 60. So this is nothing but 60 square into, what is the radius? It is mentioned in the question as 10 centimeter. So that will be simply 0.1 to the power 4 whole divided by h is given to us as 1 mm. So we convert that into meter. This will be simply 1 into 10 raised to the power minus 3. And when you solve this, what you are going to get is total power is nothing but, this is equals to 9.05 watts. This is the total power developed due to the rotation of the disk. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.